Hello, everyone, and welcome to today's webinar, which is on advanced surfacing for mold design. And this webinar today is part of a larger series that Javelin is offering called the Taste of Training, where we take small tidbits or excerpts from some of the training courses that we deliver. And well, we give you a bit of a taste as to what we do in our training. So I'll start off by introducing myself. My name is Jamie Hill, and I'm a training and process consultant here at Javelin Technologies. What I do is, well, to simplify what I do, I'm a problem hunter. So I go around to our customers, and not only do I find root causes of problems that they're facing, but I also provide solutions to those specific problems that you may have, whether that's methodologies, workflows, say you're dealing with large assemblies or imported geometry, really anything to do with SOLIDWORKS. We come in and well, we do consulting. I'm also a senior instructor and subject matter expert at Javelin. So when I am not out at customers helping them, I am here training people like yourself. I have many certifications for SOLIDWORKS, one of them being a certified SOLIDWORKS expert. So I certainly know my way around SOLIDWORKS CAD. I've been using it since 2011. Like most of you, I started off with AutoCAD and was introduced to a number of different CAD systems, and well, landed on SOLIDWORKS. I like that one the best, so that's why I'm here. Now, the webinar is on advanced surfacing for mold design. And why I chose this lesson out of our mold design book is because it touches on two subject matter areas, both surfacing and on mold design. So we'll be going through a specific lesson out of one of our training courses today. And if you're interested in further developing your knowledge and skill in these areas, you can head over to the Javelin website here. And if I go to training schedule, you can see all the courses and the times that we are currently offering, at least the public ones. And so surfacing, we have a course on November 9th ready to go. And if you're looking to take mold design, looks like we have a course running on November 30th. So sign up for those if you want to further develop your skills and knowledge in this area. So as mentioned, we're going through surfacing. Now this is kind of one of the later lessons in this course. So in the previous lessons here, we go through kind of the basics of mold design. So we start off with going through kind of the standard features. Let me open up SOLIDWORKS here. So this is my mold tools tab. And so we look at a lot of the basics. These are kind of your core mold tool features. And you kind of just run through them in a chronological order here. So you typically define a parting line, you shut off all your holes and surfaces, then you develop your parting surface and later your core and cavity. These mold design tools are fairly automatic. They're pretty intelligent, but when your geometry gets to a certain level of complexity, the automation in these tools isn't necessarily going to work for you, unfortunately. So that's where surfacing really comes into mold design. And I hope to show you a little bit of that today, where we're taking a bit of a manual approach to the mold creation. And what we're going to be taking a look at today is, well, we're taking a few parts out of this mixer here. And we'll look at a few components that might be a little bit trickier for one reason or another. So for example, on this top little part here, you know, the geometry's not the most straightforward. In this, well, we're going to have problems when we do things like try and apply our parting lines or shut off our surfaces, because we have all this tight geometry in here. We have no draft, so let's actually start by analyzing that. I generally start with these kind of valuation tools when I'm analyzing a part initially to create my molds. And so I can maybe do a draft analysis here. And you can see right away, I don't have, it's 3 degrees. Let's set this a little bit lower. So you can see I don't have draft on my part. These automated tools, especially things like the parting lines, work really well if I have draft, because what it essentially looks for is a space where it's going from draft to no draft or negative draft, I should say. And that's where it kind of takes the automation and makes my parting line for me. Now, unfortunately, because there's no draft here, it kind of relies on you to go and kind of take a manual approach to things. So let's come in here. Let's try the parting line first. So I'm going to define a pull direction. So this is how it's getting demolded. And we're going to put in our minimum draft requirement here and just analyze. This is essentially the same tool as the draft analysis. And you can see it doesn't automatically grab my edges for parting line because, well, we don't have positive going to negative. And so I could try and establish it here manually, clicking around, but this again poses another bit of an issue here. How do I create my cavity and core for kind of this feature? Where do I want to split this up? In earlier chapters, we touch on this parting line tool kind of just generally, and you'll see there is an option to split your entities or faces. So if I had vertices, I could come in and select those. And within this parting line tool, I could create my split lines. However, because let's say I want to split it right down this edge for my parting surface, parting line. There's no vertexes here, is there? So I need to step back a bit, get out of this parting line feature, and again, take a manual approach. So there's a few ways you can quickly split up your geometry or faces specifically. One of them is just to do a split line. To do a split line, I need to have some kind of sketch or curve that's defining the position of that, the geometry. So I might just come in here and start off by doing a 3D sketch. And we'll just go point down along Y. That should be fully defined. We'll do the other side as well. Now you could do this in a 2D sketch if it was a planar surface. You can see by my cursor feedback it is, but just as another alternative, I'm doing a 3D sketch here. I can take that 3D sketch and I can do a split line feature. And here I want to actually project a sketch. So we'll select that. I like to select my stuff out of my flyout feature tree here. It's not going to work. Let's try it again. That should work. There's something strange going on. Well, if that fails, let's maybe just remove the 3D and we'll revert back to our traditional 2D here. That's fine. And we'll try it again. There we go. So I'm just dividing up this face here. You can see I have my edge, and therefore I can get my parting line from that. So let's go back in, try this again. So define our pull direction. And now we could pick our edges for our parting line. So select my first one here, and you'll see some buttons pop up next to the parting line group box. And these are going to help your selections. I may very well need to select a lot of edges. So if you hover over top, it's going to show you that you can click Y to accept, or no to, or N to pick your next edge. So again, they just speed it up a little bit for me. So I'm going to hit N, that'll go in my opposite direction. And we can hit Y to continue our edge selection. And I'm just going to go around defining my parting line here. With the draft analysis built into this parting line tool, it's nice and easy to see where you probably want to split these up. Okay, that's going to finish. That's going to act as our parting line. Good. So we have our parting line. I just kind of go down the list here. So the next feature I generally use is to shut off all my surfaces here, or holes. And with this command, I always like to right click when I'm selecting a lot of edges. If possible, maybe select open loop or select tangency. It'll speed things up for you. So that'll develop my first closed or shut off surface. Do the same here. So we are selecting multiple in the one command. And then we have our patch type. So this is how it's developing these surfaces. So the first one is to create a tangent patch. So it looks at the surrounding geometry and tries to make a tangent edge. We have a contact, so this would just be a flat surface. And then we have a no fill, which we will talk about shortly. I'm going to do the tangent one here. And what I want to do is knit them specifically. So that's going to knit this into the core and cavity surface that it's automatically generating in the background. So you can see a couple things have happened after just these first two commands here. If I go into my surface body folder, you'll see a cavity folder and a subfolder for your core surfaces as well. So what it did in the background is it took my inside and outside faces of this part and copied those surfaces over, essentially, put them into the corresponding folders. You can see the muddling of colors here, meaning green is generally for your cavity, and red is for your core. The part's also red, so that doesn't really help here too much, but you can see the muddling, meaning one surface is 100% on top of the other one. They are overlapping, so it's just copied them over. Now I'm going to just hit the little eyeball here. This is kind of like a global toggle for all your visual effects. So what it's going to do is hide things like my parting line, so I don't, say, select that geometry unintentionally. Another command you'll find really useful here when you're doing mold design is to isolate certain bodies. So if I right click on a body, I can isolate it, showing my original in this case. And then I can just exit that isolation and everything is shown again. So it's really easy to flip back and forth. I could also maybe just select, say, my surface bodies and isolate, and then analyze those. So you can see how it's copied over that geometry. I use the isolate command so much, actually, that I went and set it to some hotkeys. So I just picked whatever keys make sense to me and aren't being used for something default. In this case, I for isolate, and well, use right beside it, so unisolate. So you'll see me using those throughout the webinar. So I'm going to hide, I'll just isolate these two for now. And the next one on the list here is your parting surface. Actually, I'll do this one. I'm going to do the parting surface, and we're going to, well, just let it pick up the parting line naturally. This is part of the automation with the mold tools. That's why we take the time to develop that parting line. And you can see, because of the geometry, it's not going to create a very nice parting surface for me. A lot of it's overlapping. So where the parting surface works well is with kind of perpendicular to your pull direction. So, you know, nice simple faces like this, it develops very quickly, very easily. I don't have to give it a second thought. But as soon as I get into, say, really tight or complex regions, or maybe geometry that is, say, parallel to the pull direction, it has some kind of stumbling points, I guess. So this is the tool I would naturally try and use just because it automates things. In this case, it's not going to work. So that brings us to the manual approach. And this is where a lot of your surfacing tools come into play. One of your probably most used would be a ruled surface. So if I go into this command, I'm going to say, let's start developing some surfaces. I want it perpendicular to the vector or pull direction. So we can select that same face as kind of our demolding direction. Then I could go ahead and start creating some surfaces here. You may very well need to flip the direction. So let's make this number a little bit bigger. And I want it perpendicular, so coming out to the side here. So I'm just going to highlight all of these and hit alternate direction, and you should see that flip. Good. We'll go around and do this to the other side as well. Notice I'm selecting the edges of my base part here. So this is specifically why I hid the parting line and the core and cavity surfaces that it's already developed, is just so I'm not selecting unwanted geometry or not the base part. If I was to do modifications or reload this, this is imported geometry in this case, chances are this stuff will reconnect better as opposed to if I was picking a parting line or geometry that I've kind of developed furthermore. So I'll again grab all of those, alternate face. So you can see this starting to take form. And we want a parting surface coming out here. Oh, that needs to be flipped. And we'll go do the rest here. So let's go around. I don't need to select this edge because I'm already developing the surface and pulling it out. I can save myself a few selections here. Let's flip that one. Now it would be nice if I could say right click and select tangency. On a lot of parts, we could do that. Fortunately, not here. And we're going to follow that same parting line path we took. I generally recommend to switch your faces as you go. It can get a little bit confusing if you don't, in terms of your edge selections. So let's flip that. As soon as the preview fails, that's generally a good indicator that the feature will fail as well. So as soon as I see the preview go away, I know I did something wrong. And it looks like that completes it. So what I did is I specifically left out a few little pieces here. Obviously, I can't pull this in a perpendicular direction. It needs to go down. So we'll just leave this out for now. And looking at my options here, I do want to trim and knit these together and connect the surfaces. So basically, this is all just going to be one surface. If it is joined, obviously, I can't join these, but everything else will be one. And I'll just rinse and repeat here for this little piece. So we're going to say normal to surface and start pulling these down. Again, we can flip it if necessary. And I don't need it quite this long, so let's shorten it up a little bit. That looks good. Now what I'm looking for in terms of the distance here is just for it to overlap. So if I zoom in here, you can see that furthest surfaced, so this is my surface body there, it's just passing it. You generally want surface bodies overextended. That way you can trim it back and you won't run into any issues. Okay, so you can see we have our two automated subfolders here for cavity and core, and then we have our created bodies. So all those were knitted together into one. We have that one and these two. I want to, at the end of the day, have one parting surface. So this is where I'd most likely need to trim and knit these together. I'm going to go over to my surface tab here and find my trim command. And I'm going to do a mutual trim. The mutual trim, what that does is it trims one surface by another one. So wherever these intersect, I should be able to trim them away. You can see I can trim that little piece and that. And now those should be able to be joined together. That's another feature of the mutual option in the trim surface command is it naturally knits or merges these surface bodies together. And I see one question coming in at this point. Somebody asked, why doesn't the 3D sketch work? It usually does, and I will have to look at that in a bit. I'm not 100% sure as to why that failed for me this time. It's a little bit, in general, a little bit more temperamental than 2D sketches, but it absolutely should have worked in that situation. So. Now the trim command under the mutual option here, it does naturally try and join these bodies together. Sometimes just based on the geometry, the complexity, it doesn't by default. So you can see in this case, I'm still actually left with 4 surface bodies. So keep an eye out for that. No big deal if it doesn't merge it. We can always just do it after the fact. So I'm going to go into a knit surface command, and we'll just grab all these and knit it together ourselves. So I'm just going to merge. And now we can see this is now one parting line surface. A good indicator to just visually tell where you have open surfaces is this kind of blue outline. If I have joined edges, you'll see a black outline. I have my settings set to, if there is a tangency, to show a phantom or dashed line. But if I have surface bodies specifically and open surface bodies, I'll see this blue edge. So I saw right off the bat that all these kind of blue edges along here went away. So I don't necessarily need to look at my solid body folder. So I have my parting surface. I'm going to exit my isolation here. And what I need to do is, well, through the mold tool automation, it naturally wants to create 3 of these subfolders, one for the cavity, one for the core, and then another one for my parting surface. That's, again, going back to the automation of these tools. In this case, because we created the parting surface manually, I don't have that subfolder. I wouldn't create one. All you need to do is go up here and say insert your mold folders. And now I can take that parting surface and drag it into the appropriate folder. So now everything is starting to be a lot cleaner. I'm pretty much ready at this point to create my cavity and core. But if I'm looking around and analyzing this a little bit, well, this might not be too good for my tooling. It's pretty skinny in here. I'd be worried about my tooling breaking or warping or whatever the case may be. So let's go ahead and adjust this manually. Some really useful tools that I like to use is direct editing tools. We could just kind of manipulate things on the fly. We don't really have to put a whole lot of thought into it or rework our whole feature tree to get our end result. Something like a move face specifically is a really powerful one. Here I can offset surfaces or solids. I could translate, rotate. In this case, I'm just going to translate it. I'm going to simply take that face and say, I want to move that down. So let's give it some intelligence here with end conditions. I'm going to say up to vertex. So our from point, let's maybe pick a point here. And our new location, we'll just drive it down to the bottom. And our direction, something like that. You can see the direction that it's trying to translate it in, which is incorrect. So we can just flip that. And again, now we see our preview. So now I'm feeling kind of confident about this. Let's go in and do the other one as well. We see our preview, perfect. Let's hit OK. So you can see how it just follows. But this creates yet another problem here is now we have a hole. In order to create our cavity and core, we do need a watertight surface. So these developed surface that it created. Let's go in and maybe just manually patch this up. So fill surface is a really nice one for patching. Just select your surrounding edges. See my preview. We could say apply to all edges. So you can see the continuity conditions here for each edge specifically. So I can say apply to all, save me a couple clicks. And let's not do contact, but just to make sure our material is flowing and everything's continuous, I at least like to do curvature continuous, which is kind of like a C2 continuity condition. And in this case, it's still going to be flat. I mean, this is all planar, but I just like to get in that habit in case we do have kind of curved geometry that I need to follow. And we'll do the same on the other side. You see our preview, set it to curvature. Generally, I set it to curvature. If that fails, I start stepping it back from a C2 condition to a C1 to a C0. Good. So I have these two surfaces that I just created. Another thing you'll want to look out for here, because I went and did the move face and I modified where that face is, it naturally kind of just drops it out of that folder, thinking that it's an exception. So we do want to move that parting surface back into that folder. We do have these two leftover ones. Now remember that we need a watertight surface on both the cavity and the core, meaning I could take these surfaces and put it into my cavity folder. It'll recognize that as a watertight cavity, but I'm now forgetting about my core. So that's simple to remedy here. We're going to do an offset surface. And this command is kind of a twofold command where I can offset it, but if I put in 0 for the value, you'll see it switches to copy surface. So whether you select the surface bodies in the flyout tree or just graphically, we'll just copy those. Good. So now we can take both of them and put them into their appropriate folders here. And yes, so my core and cavity will be meeting here. All right, and just to make sure, I like to grab, say, all the cavity, hit isolate, and I can take a look, see if it's watertight. Everything looks appropriate there. Look at the other side. And that seems to be good as well. So at this point, we can go ahead and create our core and cavity. this starts off with a sketch. I need to define the size of these things. So I'll just go onto any kind of plane or surface. I'll create my block size here. And associate it to my origin. There you go. So that's fully defined. It's also fully encompassed by the parting surface. While I have that sketch pre-selected, I'll go into my tooling split. You can start to see a preview develop here, and I can specify specific sizes for each half. You can see how it automatically selected all those surfaces because I put them into the appropriate folders. You could create a temporary plane. It just so happens that I maybe wanted to use that face as my splitting point, but you could always create a plane as reference if that works better for you to, say, define it in the center or something like that. And we get our halves. So at this point, it's just cleanup. So some best practices here is to get rid of your reference bodies. All these surface bodies really aren't doing anything for me at this point. This is kind of what I'm after in the long run. So I can come in here, just right click on your top level surface body folder, and that'll allow me to quickly delete all the bodies, pre-select them. Now all those bodies are deleted. I generally leave this for the very last feature in my part. And now we're left with our part and core and cavity. So to help you visualize this a little bit, now in our parts, we can do an exploded view. So just right click on your configuration, new exploded view. And just like our assemblies, we can go ahead and step these guys out. Perfect. So you can see that would be the kind of mating surface between the two. Now, if you really want to make this nice and pretty and clean, let's maybe isolate this. And one thing I won't do is work with this exploded view on. Not a lot of tools actually work with it on, so I'll collapse it. But luckily the isolation stays. So I'm now working on my cavity. And if I wanted to clean this up, this is all really one surface. So I could, for example, just come in and do a quick delete. So delete these faces here. And the delete and patch is generally what I like to use if it'll work. And what this does is kind of brings out the underlying geometry. And it will now get rid of that little bit of kind of remnants, if you will. I will stress that you do need to be careful with this, especially if you're doing something like a delete and fill, tangent fill, because this is creating brand new geometry. So you could be messing things up if you were to go this route. So let's just delete and patch. Generally, if that patch doesn't work, I just leave it. It's not going to cause any harm in any way. And so at this point, this is now all in a multi-body file. If I wanted to push these parts out, one of the commands, there's several ways to do it, but one of my favorites is just right click on your solid bodies folder and you could do a save bodies. Here I can select all the bodies, save them out to their specific part files. That way in, say, PDM, if you are a PDM customer, you have revision control now on each part. And this essentially is a master model, if you will. And why I like this save bodies is, well, it'll create an assembly for me automatically. So I just browse, give it a name, location, hit OK, and we've now got our 3 parts and an automatically generated assembly. Let's take a look at another part from this mixer. So for this body or handle, the parting line, the thing that was a bit tricky on the last part, is actually pretty easy here. You can see this is where our positive draft meets our negative draft. So the automation behind it is nice and quick to use. So I can do a parting line. I can select maybe a piece of reference geometry as my pull direction. And you can see it, well, it went after the wrong area here. So I'm just going to right click and clear this selection. And this is where my right click saves me a bunch of time. So right click, select tangency. That will select my outer loop, and we can just hit go. So that's going to develop my parting line nice and quick. Somebody asked if the webinar will be available for you to view later, and I believe it will, yes. Now, this is where it gets a little bit tricky on this component, is I have some surfaces or holes that I need to shut off. So that's naturally our next feature to go to. And I could start selecting these things, try to maybe fill the gap. I would always go into the shut off surfaces as kind of my first go-to. But unfortunately, sometimes it doesn't always work. So again, here you have the Y and N to speed up your selections. So I see a preview that's going to generate, whether it's contact or tangent. I think they actually got those selections a little bit backwards there, but works nonetheless. Now, as you can imagine, for this shut off, that gets a lot more complex. I'm still going to go around and figure out my parting area or surface. You will notice a tangent propagation button does pop up, which may hinder or help you. In this case, it didn't help too much, did it? So as long as you could see a tangent path, a logical path for it to follow, I generally use that option, but sometimes it doesn't really help you. Luckily, we have split faces here that I can just kind of follow. If not, I could just do another split line or maybe some curve features to split up that face. Good, and we'll complete that. Right away, I see, well, my preview failed, didn't it? I'll probably try my various options here. If you have a lot of shut-off surfaces, and you find this is starting to bog down your computer a little bit, I'd recommend turning off the preview. It's going to help. So I'll try both of these options, both tangent and just contact. I still don't see a preview though, so it's going to fail. What I want to do here is just do a no fill. So what this will do is it defines that as my parting region, but it doesn't necessarily come in and, oh, forgot this one, didn't I? It doesn't necessarily develop any surfaces, but this will still kind of be the split between cavity and core. So we'll do no fill, and I'll just hit OK. So I still get my folders here. You can see how it's developed those surfaces, but I now need to go and take more of a manual approach to fill these. Again, I'm just going to isolate my solid body. I like to refer all my geometry back to that, and maybe not the automatically generated surfaces. So let's break this up into chunks. That's generally the easiest approach. You can imagine trying to develop a surface that goes kind of in this area. It's going to be interpolated for the most part. It's not going to be really well defined or, well, really what you want. So I'm going to divide it up into nice small chunks that are easy to develop my surfaces. I could do a 3D sketch to maybe say grab this edge going between these points here. Just point to point in a 3D sketch, that would work. I could also do some curves. So as an alternative, let's maybe do a curve through reference points. You can see that'll create a curve there for me. And I'm gonna turn my parting line off. So fill surface is probably one of your best friends here. We just pick our edges. And this will just be contact. And we'll do this a couple more times. Get that in there. Now, what I don't want to do is merge these surfaces. Remember, we need these manually developed surfaces both for the core and cavity, like we showed you on the last case study there. So not that the merge option is available, but I'm just not going to use that for now anyways, because it would merge it to, say, those surface bodies. Let's go up to the top here, shut this off. So I'm going to do a planar surface. We can just say develop it between those two pieces there. Good. And then again, split it up into bite-sized chunks that are easy to work with. You'll save yourself a lot of headaches. So let's do another curve. And let's maybe put a couple more. Okay. This is probably where something like a 3D sketch actually might make a little bit more sense, because I could do all of these lines in one sketch as opposed to 3 curves, but they all work the same at the end of the day. Okay, so there's one. Now this just becomes kind of rinse and repeat, doesn't it? Remember all those buttons you have on your right-click menu, select open loop, select tangency. If you can use them, it will absolutely save you time in all this kind of edge selection that we're doing. Good, and now for the tricky part, fixing this. Here I'm going to do a loft. So a loft is interpolated from one profile to the other. It's going to say go from this line over to this line and create a surface, interpolate in between. So what I want to do is group a few edges into one profile. To do this, I can right click and use my selection manager. Essentially, this just takes several entities and groups it into one. So now I'll say 4 of those edges or 3 of those edges is just one grouping. Do the same on the other side here. Good, and you can see that being generated. Now what I need to do is conform it to, well, the top and the bottom here. So we can apply some guide curves. Again, I'll need to use my selection manager because this is broken up. We can use our tangent propagation to speed that up a little bit. You can see how it starts to warp. Pick my other edge here as another guide curve. Now, depending on how you want your geometry here, you can change your influence type. So what it's doing is it's taking this guide curve and pushing that through to, well, right up until the next guide curve. But if I want, say, a hard edge here, straight edge, I can maybe say just influence this up to the next sharp. You'll see that straighten out. So that's going to get our new surface in there. Now, if I turn all the curves off, I'll just hide them all there. You can see all those blue edges indicating open surfaces. Matter of fact, you could also see that in my surface folder here. So what I'm going to do is isolate those specifically. So we have both our front and back, and now I can knit them together. So make one surface out of this, merge them. You can see those edges turn black, and we'll do the same again on the back side. And now what we need to do is copy them. So offset, because I need a surface for both the cavity and the core. So now we have 4, just like last time. So again, I'll take these 2, drop them into the cavity, drop these into the core. And there's our manually created shut-off surfaces. What's going on there? There we go. Nope, didn't want to take that. Let's try it again. Did I forget a piece? So you can see you hit a rebuild and it's rejecting it. And I just so happen to have forgotten a piece. So let's maybe roll back in time a little bit here. And I'll just isolate that one body. Actually, and these guys. So take that. This one, isolate. And we'll fill that hole quickly here. So. Roll it back down. I need to incorporate that into my knit. Back should be fine. Make sure this is also incorporated into my offset. Good. And let's try this one more time. So I was rejecting those surfaces because they weren't watertight. Control Q now, and it's apparently still going to do. Let's see why. Let's put in our mold folders here, and we're going to do our parting surface. I'll come back to that. Not too sure why that's giving me some trouble now. So we'll just develop our parting surface. Okay, and this is planar, so we can go ahead and do our core cavity profile here. While that's pre-selected, we'll come in and do our tooling split. So it did select them. Might have just been a bit of a bug. Good, so it worked. Now this isn't going to be manufacturable because of the handle. Right, we have this big hole in here. Now typically I'd use the core command, but to use this command, if we go inside of it, we would typically come in here. I could grab some geometry, convert that, and use that to create my core. All right, so this would attempt to develop my core. The only problem is it needs a body to end on, and well, I have open space, so that's why this is going to fail, unfortunately. So again, we need to take a bit of a manual approach to create our side cores here. What I'm going to do is another fill surface. We're going to create a split in here. Sorry, folks, I can see it's almost 3 o'clock, so I'm just going to be going a little bit over time. We'll just create a filled surface contact. And then what I can do is I can actually copy surfaces from my model with the knit surface command as well. So I can say knit this together along with all this other geometry. I don't necessarily have to copy it and then knit it together. So that'll save me an extra feature. Make sure you get all these little artifacts. So zoom in, look closely. and that will copy that. So let's now isolate that surface. We're going to work with this one. I need to extend this. So again, a ruled surface is probably your best friend here. You can right click, select open loop, and extend this. I want this in a specific direction, so we can maybe say tapered to vector. There we go. So now that should be, hopefully, protruding through my block. Good. I'm going to do a knit to get these knit together. So merge, don't create a solid though. Now that is one surface body. We can, of course, mirror surface bodies to save me repeating all these steps again. Let's isolate that. Mirror about that face. Bodies will be these. Don't merge, don't knit. Good. And now to get our side chords, all we need to do is a Boolean operation here. So split is very useful. It's kind of dual purpose, where this can split up my physical geometry as well as save out the part files. So my splitting tools will be these bodies, and I could say I want to cut or create my side cores out of that original. And so you can see I have 3 bodies from this one original, and I'm just gonna give it little check marks here, basically saying keep these. If I give it a file name, that's when it creates an external file with these specific bodies. If I don't give it a name, it just cuts them up. So again, best practice here, just delete all this essentially reference geometry, surface bodies. That's my final step. And now I might go in and do my exploded view again. So that's how to create your manual course. Here's a perfect example of where I come in and say I want to clean up this face, make it joined. Let's isolate this body and then get out of our exploded view. So I could delete and maybe grab this, say delete and patch. It's going to fail on me, so I might try the delete and fill. Now, if you look carefully, doesn't look like much change there. It joined the faces. But if you're not being careful here and not analyzing what you've done, lo and behold, you can see it's actually changed my geometry. So now this is, going to have a gap in it. Not too good. So I delete that. You can see that should be perfectly flush. All right, everyone. Sorry for going a couple minutes over there. Hope you all learned something from today's webinar. I'm just going to go through a couple of the questions if there is any. Looks like they are answered. So if you want to learn more about surfacing or mold design, look into some of Javelin's courses. We have top-notch instructors ready to help you out, and we're not in such a time constraint during actual training, so we can get a little bit more one-on-one time. You could unmute yourself, ask questions freely, and get some personalized answers for you. Fortunately, hard to do that in a webinar, but again, hope everybody learned something today. If there's no other questions, we will wrap it up. All right, everyone. Enjoy your evening or afternoon, wherever you may be, and I hope to see you again. Bye for now.